Okay, this movie is going to help us find the growth from a table, and the x values are not increasing by 1, similar to what we had in the last classwork. So when the x values are increasing by 1, we know how to find a linear function. We look and we check for the growth. We see that our f of x values are going down by 2. So we can show our work. We start with 25. And then to get from 25 to 23, we have to go down 2. So 25 minus 2 is how we got our 23. To get our 21, we go 25 minus 2 and then minus 2 again. To get to the 19, we go 25 minus 2 minus 2 minus 2. To get to the 17, we go 25 minus 2 minus 2 minus 2 minus 2. And to get to the 15, 25 minus 2 minus 2 minus 2 minus 2 minus 2. Great. So we already know how to do this. So this is not new. This is easy. So we have 25 there, 25 minus 2, 25 minus 2 times 2, 25 minus 2 times 3, 25 minus 2 times 4, 25 minus 2 times 5. So if we wanted to go ahead and find what happens when x is 100, in other words, if we're looking for f of 100, well, we can see over here everything's the same. 25 minus 2, except for what we're multiplying that 2 by, which represents the number of times we're subtracting 2. So we can notice here that this number 2 is 1 less than our x value. Why? Because we didn't have to subtract 2 to get to this first one, so we subtract 2 here and here only. So we subtracted 2 twice. When we got down to here, we subtracted 2 5 times. When x was 6. So when x is 100, we'll subtract 2 99 times. So then we can do x. We know that f of x is going to be the 25 minus 2 times one number less than x. In other words, x minus 1. So we have our function. I went through that quickly because that's review. We've already done that. That's the same thing that we saw in another homework assignment. So what happens here? Notice I used the same f of x values. We're still going down by 2. So we could do the same thing there. When we get to our work, still the same thing. Everything is exactly the same. To get to this 19, we have 25 minus 2 minus 2 minus 2. Everything's the same. So that means all this part is the same as well. But now what happens? When we get to 100 and we're looking for f of 100, we have to think, well, 25 minus 2 times what? And we look back here and we notice, okay, so this changes from 2, 3, 4, 5. This is 9, 13, 17, 21. So we're looking for a relationship between this 21 and this 5. But there is a relationship, but it's very difficult to find. I'm not sure how we would go about doing that. But if we can't find that relationship, there's no way for us to find what f of 100 is. So we're stuck. Why? Because these numbers did not go up by 1. These numbers were going up by 4 every time instead of 1. So because we were going up by 4, it made it much more difficult to find a relationship between the part that's changing in our work for our dependent variable and our independent variable. So if we can't find f of 100, we certainly can't find f of x. We still know it's 25 minus 2 times something, but we don't know what that something is. So what do? Well, it was very helpful when we had the x's going up by 1. So let's make that happen. Let's make a new table, and we'll put in our 1, and we'll put in our 5. We don't know these other numbers, but maybe we can try to find them. So let's look. So this is the same table. We're just looking at 1 through 5. I even put 6 in there just for fun. And let's see what happens. Well, we need to take some jumps to get down to 23, from 25 to 23. But we don't know what those jumps are. If we did, it would be easy. What we do know is that there are going to be 4 jumps. Why 4 jumps? Because when we get from 1 to 5, that's 4 higher. So that means we're going to take 4 jumps to get from 25 to 23. And in that time, when we took 4 jumps, the value went down by 2. So it takes 4 jumps to go down by 2. We need to figure out how much each of those jumps is. So if we're looking to see how much each of those jumps is, we can just divide the 2, this negative 2, by 4. Right? We're dividing this big jump up into 4 equal parts. So negative 2 divided by 4 is going to be negative 0.5. In other words, each jump goes down by negative 0.5. There we go. Well, now we have something familiar. Now we know what we can do. So 25 minus 0.5, 25 minus 0.5 minus 0.5. Right? We can keep doing that. Just like we did before, it's the same thing. Look, I think I have an extra 0.5 in here on accident. Just be careful. You might want to write it down correctly because this looks wrong by a little bit. But by this point, the process should be easy. So we have 25, 25 minus 0.5, 25 minus 0.5 twice, 25 minus 0.5 3 times, 25 minus 0.5 4 times, 25 minus 0.5 5 times. So now, once we get to 100, if we're looking for f of 100, we know we found a relationship here. It's easy. This number is 1 less than this number. So this part that's changing in our dependent variable is 1 less than our independent variable. So for f of 100, we should have 25 minus 0.5 times 99. With x, if we have f of x, it's going to be 25 minus 0.5 times x minus 1. There we go. Let's look at one more example. So here, we kind of mix things up. We're going up by a whole bunch of stuff. So here, if we have plus 5, and we go up by 5 in the x's, we're going down by 12.5 in the f of x's. So that means it takes 5 jumps to go down 12.5. So how much will it go down with 1 jump? Well, we have to divide that negative 12.5 into 5 equal jumps, getting us negative 2.5. We could look at the next one. From 6 to 9, we're going up by 3. And when we went up by 3, our f of x values go down by 7.5. So it takes 3 jumps to go down by 7.5. Negative 7.5 divided by 3 is also negative 2.5. It's the same growth. So it seems like this is a linear relationship because the growth appears to be constant. We can check with the other ones. Go up by 2, down by 5, up by 4, down by 10, up by 6, down by 15. And if we do the same divisions, we should see that we get negative 2.5 every time. So it looks like we have some linear growth happening here. So now let's try to build that function. If we're going from 1 to 6, why? Because that's what I had here. I didn't have to choose these two numbers. I could have chosen any two that I had. It didn't have to be the first two. But I think it's kind of easier to start with lower numbers. So we knew the x value. We knew f of 1 was 12. We knew f of 6 is negative 0.5. That's coming from over here. And now we know each jump is going to be negative 2.5. So if we want to show our work, we have 12. 12 minus 2.5. 12 minus 2.5 minus 2.5. Now it's the same process we've been doing over and over and over and over and over again. So here, to get down to this one, we did negative 2.5 5 times. 5 is 1 less than 6. So now we can find f of 100. F of 100 is 12 minus 2.5 times one number less than 100, which is 99. So then we could also find x. F of x is 12 minus 2.5. How many jumps of 2.5? 1 less than x, or x minus 1. So there is our function. Hopefully this was helpful and can help you do that classwork that we were working on.